Students, we are going to do a numerical from chapter heat, and this had come in ICSE board 2016. So there are two numericals, and before we move into the numericals, let us understand about the concept. So what happens whenever there are two bodies, one which is at a higher temperature and it is mixed with a body which is at lower temperature. So under an ideal condition, we say that the heat lost by hot body is equals to heat gained by cold body. So essentially there are two bodies, one would be hot and one cold. Now hot body is at a higher temperature and cold body is at a lower temperature. And when both of them are mixed together, so the heat will get transferred from hot body to cold body till the temperature in both the bodies is same. Okay, so heat transferred or heat lost by hot body will be given by M, mass of the hot body, C, specific heat capacity of the hot body, into delta T. Okay, while heat gained by the cold body, okay, so let me write mass as M1, specific heat capacity as C1, and delta T1. Now understand, hot body would be at a higher temperature and cold body would be at a lower temperature. So when they are mixed, so delta T we have to find for these bodies separately, and as per the principle of calorimetry, these heat lost by the hot body equals heat gained by the cold body. Another thing which we need to understand is about change of phase. So whenever there is a change of phase of ice to water or water to steam, what happens during that phase is, if we measure the temperature of ice at 0 degrees Celsius when heat is being supplied, we will find that for quite some time there is no raise in temperature even though heat is being supplied. So where is this heat being used up? Now this heat is being used up in increasing the potential energy of the molecules of the solid, which results in escaping of the molecules. So the intermolecular space increases and finally the solid becomes liquid. Okay, same thing happens whenever there is a change of phase of liquid to gas. Now whenever there is change of phase, heat required for change of phase Q is given by ml. Okay, while whenever there is increase in temperature for the same solid or liquid, heat is given by Q equals mc delta T. These are the things which we have to understand. Okay, now just for explanation, if there is ice which is at, let us say, minus 10 degrees Celsius, okay, and this is my 0, okay, let me keep this as 50 and maybe this as 100 degrees Celsius. Okay, now if we are supplying, let us say there is m grams of ice, and so if we supply heat, so if the ice is at minus 10 degrees centigrade, you will find that temperature shows increase till 0, and then from 0 for quite some time you will find that there is no increase, and then after that it increases. Okay, and then again at 100 there is this line and then it increases. So if I name it as A, B, C, D, E and F. Now between A, B, C, D and E, F, heat is given by Q equals mc delta T. Okay, where we take specific heat capacity of, in case of AB, ice, in case of CD, water, and in case of EF, steam. And between BC and DE, Q is given by ml, where L is latent heat of fusion between B and C, while between D and E it would be latent heat of vaporization. Now these values are given in the questions to us. Okay, and please understand, whenever there is the reverse flow, which is steam being condensed to become liquid and then liquid is being condensed to become ice, the same thing happens in reverse direction. So in that case, heat is given by the steam to become liquid, and then at 100 degrees Celsius, steam to become water, the heat given would be ml, and between D and C again we will have water mc delta T. Again between C and B, when water at 0 is becoming ice at 0 degrees Celsius, it is ml, and then again from B to A, heat would be mc delta T. Now with this thing in mind, let us try solving the question which is given. So it says a copper vessel of mass 100 gram contains 150 grams of water at 50 degrees centigrade. How much ice is needed to cool it to 5 degrees Celsius? Given specific heat capacity of these substances are given. Now let us understand, in this question the hot body is your copper vessel, so Cu vessel, okay, whose mass m1 is given as 100 grams, okay, and its temperature is 50 degree. So let me write temperature T1 is 50 degrees Celsius, okay, and final temperature is 5 degree Celsius. So what is the change in temperature? Change in temperature delta T would be 50 minus 5, which is 45 degree Celsius. So what is the heat lost by copper, okay, vessel? It would be given by, let me write it as Q1, which would be, again I will use mc delta T. So m is 100, C is given 0.4, and delta T is 45. So this would be 1800 joules. Now understand, this copper vessel contains water. So water again is hot body. So what will happen for water? We will see that the mass of water M2 is 150 grams, okay, and understand that the change in temperature for water also is 45 degree Celsius only. So I write delta T as 45 degree Celsius, okay. So now what will happen here? So now Q2, which is heat lost by water in this process, would be 150, which is the weight of water, into 4.2 into 45, okay. So which would come to 28,350 joules. So the total heat loss, so if I have to find heat lost, it is Q1 plus Q2, okay, which is equals to 1800 joules plus 28,350 joules, okay. So if you add this is 30,150 joules of heat which is lost. Now let us understand what is happening with ice. We have to find the mass of ice. Now let us say, and now this is what? This is our cold body. So let us say mass of ice here, okay, mass of ice, let us say it is m, okay. Now ice is at 0 degree Celsius. What will happen to ice? First, it will convert into water at 0 degree Celsius. So, what is the heat required for this change of phase? So, for that, what will we do? As I told you, Q equals ml. Why? Because m grams of ice is getting converted into, so I am writing it, m gram of ice getting converted to m gram of water at 0 degree Celsius. So it is given by ml. Now this would be what? So let me write this as Q3. It would be 336 m. Once we have got m grams of water at 0 degree Celsius, now what will happen? Since the final temperature is 5 degrees Celsius, so mass of water at 0 degree is m and final temperature TF is 5 degrees Celsius. So how will we find the heat lost by this cold water? So Q4 would be given by MC delta T. Now MC is 4.2 into change in temperature, 5 minus 0 is 5. So you get 21 M. So what is the heat gained? Total heat gained is Q3 plus Q4. So which is 336 M plus 21 M, which is equals to 357 M. Now what will we do? So now as per principle of calorimetry, heat gained equals heat lost. So 357 M is equals to 30,150 joules and M equals 30150 divided by 357. Yeah, and if you solve this, you will get 84.45 grams of ice. Okay, so this is how we do this question. Okay, now let us go to the second question, which is calculate the mass of ice required to lower the temperature of 300 grams of water, which is at 40 degrees centigrade, to water at 0 degree centigrade or Celsius. Okay, so now let us go and solve this question. Yeah, so let me start. So what is happening here? So mass of water given, so this is our question D. Okay, so mass of water is 300 grams. Okay, temperature is given as 40 degrees Celsius. Okay, and the question says that it will become 0 degree. Yeah, this is what the question says. So final temperature is 0 degree Celsius. So delta T is going to be 40 degree. Okay, and now what will happen? So what is the heat lost? So heat lost would be MC delta T. So which is equals to 300 into 4.2 into 40. So this is what we will have. Yeah. Now let us understand what is happening to cold body, which is ice here. Now it says mass of ice, which we have to find. Okay, so mass of ice, let us say, is M. Okay, and this ice is going to convert to water at 0 degree Celsius. Okay, so what is the heat gained by this? It would be given by ml. Okay, so which is 336 M. Now understand the final temperature is 0 degrees Celsius only. So we don't have to now worry about water at 0 degrees Celsius because the final temperature is 0. Okay. So this means my heat lost is equals to 336 M. So now let us do that. So we will have 336 M equals 300 into 4.2 into 40. So which will give me M equals 300 into 4.2 into 40 divided by 336. Okay. So now this will give you mass of the ice. So which is, okay, let me just quickly solve this. So which is 300 into 4.2 into 40, and this is divided by 336, which gives us 150. So this is what we will have. We will have 150 grams of ice which is required for this. Okay. So this is how we approach these kind of questions. Again, just for understanding, heat lost is equals to heat gained, that is principle of calorimetry. Whenever there is change of phase, heat is given as ml, and whenever there is change in temperature for the same substance or same phase like solid or liquid or gas, heat is given by mc delta T. Okay. So this is how you are supposed to solve these questions. Okay. If you have not subscribed to the channel, I would request you to subscribe to the channel. Also, please share your feedback, whether you have liked the video or not. Share with me what is it that you would want in the video so that I can help you in a better way. Also, please share the video with your friends so that others can also benefit. Thank you.